Hi guys, this is Miss Kate. So I hope everyone's having a good weekend. We're going to start doing our Unit 2 review on this video. So the first thing that we did in Unit 2 was solving multi-step equations. And I don't know if you guys remember, but these were a little bit more challenging than the ones you saw last year. So I'm going to go through the first one step by step, and I want you guys to remember that it's really important that you check your answer at the end of solving. So what I'm going to do first is use the distributive property. I'm going to take my 3/5 and I'm going to distribute it to both terms inside the parentheses. So when I multiply 3/5 times 10x, I'm going to end up with 6x. And then I'm going to also multiply 3/5 times 15, which is going to give me a -9. I'm just going to scroll down a little. Okay, and then we still have that set equal to -2. So now in order to solve for x, I'm going to bring the 9 to the other side of the equal sign so that I can begin to isolate the x. And I'm going to now be left with 6x is equal to -2 plus 9 is going to give me 7. Okay, I'm just going to wait a second, make sure everyone's on the same track. All right, the last thing I'm going to do is I'm going to divide both sides by 6, and I'm going to be left with x is equal to 7 over 6. Now, it's okay if you get a fraction, and I don't want you to freak out if that does happen, but let's go ahead and just double check that we did this correctly. So in order to check, I'm just going to rewrite my equation from the beginning, which is 3/5 times 10x minus 15. And I want to see if I do plug in 7 over 6, will I end up with -2? So I'm going to write 3/5, and then again I have 10 times 7 over 6 minus 15. And I want to see if that's going to give me -2. I'm just going to scroll down. So I still have my 3/5 on the outside. And in order to multiply 10, I'm going to just divide both of these by 2. So this is going to be 3 and this is going to be 5. I'm going to now multiply 5 times 7, which is 35, over 3, minus 15. And I want to see is that equal to -2. And now what I'm going to do is I'm going to distribute the 3/5. So I'm going to multiply 3/5 times 35 over 3 minus, this should say 3/5 times 15. And again, I'm basically asking myself, does that equal -2? So when I multiply 3/5 times 35 over 3, you can see I'm doing some canceling. I'm left with 7 minus, again, I'm going to do some canceling here. This is 1 and this is 3, minus 9. And look what happens. 7 minus 9 is -2. We did it correct. So just remember, just to reiterate, when we're solving these multi-step equations, you want to remember the distributive property, and you want to remember that whatever is on the outside, you're going to distribute to every term that's in the inside of the parentheses. And then don't forget to check your work. Okay, the next thing that we went over in Unit 2 was translating. And it's really important that we go over some keywords when you see translations. So let's first talk about subtraction and also just some other keywords that I think are really important. If you guys remember, we always said that whenever you see the word is, it means equals. And you can always represent a number using x. Now, the things about subtraction that are really important are the keywords less than, subtracted from, and the difference. And I would just star these two because that, if you recall, means that we need to switch the order. So let's see if we have an example. So if I wrote 6 subtracted from a number, because the 6 is actually written first, I'm going to end up writing it second when I write it mathematically. And the same goes with less than. If I say 1,414 less than a number, I'm actually going to write x minus 1,414. Many of you may get caught and write 1,414 minus x, but you have to remember when you see less than or subtracted from, switching the order. We didn't really do much with fewer than, so I would kind of just ignore that for now. Okay. In addition, we spoke about division. I want you guys to remember that quotient is a key word for division, and divided by is also another key word. And the key to those key words is that whichever comes first in the sentence goes, I'm going to say, on top, which, as you remember, is the numerator. So a number, okay, so that's written first, divided by 18. So that means that x is going to go as the numerator and then divided by 18. And the same here, the quotient of 14 and a number. So I'm actually going to write 14 as the numerator, and then x would be the denominator. So quotient and divided by, the key thing is that whichever is written first in the sentence goes on top, or I'm going to actually write numerator. Okay. The next idea was parentheses, and this is just something I wanted to bring up because it seems like a lot of you have trouble when you do see parentheses. So a couple of things that you can remember. Times the sum means that you're going to have a parenthesis and there's going to be some form of addition inside the parentheses, as opposed to times the difference, where you'd also have parentheses and you'd have subtraction going on. And you might also see something like twice the sum, which would mean we would have a 2 on the outside and then something would be added inside the parentheses. And twice, remember, is going to translate to 2 times something. So let's look at these few examples and see if a parentheses will be needed. So this just says a number plus 6. So in that case, we actually don't even need the parentheses because there's just one operation going on. Now, number 2, however, is telling us that we need to do 4 less than the quotient of a number and 3 is 20. So there's a lot going on here. So 4 less than the quotient of a number and 3 is 20. Okay, so I actually don't think we need parentheses for this one either, but I still want to go through and translate it and make it a mathematical and actually equation. So we have our less than, so I'm going to star that and just write that. Remember, we need to switch the order. So I don't want anyone to write 4 minus. Instead, it's going to be minus 4. Now we have a quotient of a number and 3. So here's our quotient rule. Because a number is written first, that's actually going to be placed on the top. And then a number and 3. And then we have the is equals 20. So that says 4 less than the quotient of a number and 3 is 20. Okay, and number 3 I think has to do with parentheses. 4 times the sum, so that's the key thing, times the sum of a number and 6. So first let's write what a sum of a number and 6 would look like. And then it's saying multiply 4 by that entire thing. It's saying don't just multiply 4 by x, however, multiply 4 by the sum of x plus 6. So that is definitely one I would star, maybe even put some exclamation marks because it's very important, and you'll definitely see that as we continue to review and take our tests. Okay, so let's just try 2 examples. And we want to solve these. When a number is doubled, so we don't know what the number is, so I'm just going to write x. And remember, doubled just means multiplied by 2 and subtracted from 3. The result is, so there's our is, that equal sign, negative 17. And they're telling us to find the number. So I first have to take my number and double it. And then remember, I'm subtracting that whole thing from 3. So I have 3, and then I'm going to subtract 2x from it. And I'm going to then set that equal to negative 17. Now here we go again with solving our multi-step equation. Now some of you may like to draw the line down your equal sign just to help you keep everything balanced. If you do, I'm going to do it that way. So first I'm going to subtract 3 from both sides. Okay, and I'm going to bring down my negative 2x. And I'm going to set that equal to a negative 17 minus 3 is going to give me a negative 20. And then I'm going to go ahead and divide by negative 2. And my result is going to be x is equal to 10. And now what do I need to do at the end? Definitely check. So I'm going to rewrite my equation. 3 minus 2x is equal to negative 17. And then I'm going to go ahead and substitute in my value. So PEMDAS, I'm going to follow order of operations. I'm going to do my multiplication first. 3 minus 20. Does that equal negative 17? And looks like we did it correctly. Okay, and one more. 5 times the sum of 3 times a number and 4 is 65. Ooh, this is very wordy. All right, so let's just break this up. I want to first just talk about the sum of 3 times a number and 4. I'm going to kind of forget about 5 times because I can just put that on the outside of my parentheses. So remember, sum indicates addition. 3 times a number we know can be represented as 3x. And then we have a 4. So I want to add 3x plus 4. And then they're telling me to multiply that by 5. And they tell me that this is equal to 65. Now, the nice thing about that is they don't ask us to solve it, but I am going to go through and just show you the steps of how I would solve it. Again, I'm going to take that 5 and I'm going to distribute it to both terms. So I'm going to be left with 15x plus 20, and that is equal to 65. I'm going to go ahead and draw my line, subtract 20 from both sides, and I have 15x now is equal to 45, and then I'm going to go ahead and divide. And I'll be left with x is equal to 3. And then the last step would be to check. So if I go ahead, I rewrite my equation, 5 times 3x plus 4. And I'm going to substitute in what I found was 3. So 5 times 3 times 3 plus 4. And let's see if this works. 3 times 3 is 9, plus 4 is 13. So it looks like I may have made a mistake. Let's see what I may have done. 15x plus 20 is 65, 4. Let's see. Say 15x plus 20 is equal to 65. Let me make sure I did my equation correctly. Okay, so the sum of 3 times a number and 4, so 3x plus 4, good. 5 times that, okay. So I have 5x plus 20 is equal to 65. Then I subtract 20 from both sides. So I get 15x is equal to 45. And then 45 divided by 15 is 3. Okay, I'm going to keep going. Is equal to 65. Oh, I'm sorry. I'm good. Okay, and then 5 times 13, yes, is 65, which equals 65. Okay, sorry, just a little bit of a brain freeze. Okay, so that's how we would go ahead and translate, solve, and check. All right, the next thing we spoke about were literal equations. And if you remember, we asked during this lesson, what is a literal equation anyway? So a literal equation is an equation with 2 or more different variables. Okay, so you're going to see 2 or more letters. That's the simplest way to put it. So an example would be something like ax plus k is equal to d. In this example, there's actually 1, 2, 3, 4 unknowns. And then another example would be something like 12x plus 2y is equal to 10, where the x and y would be our 2 variables. So if you see an equation with more than one variable, we can call it a literal equation. So the question is, what are we going to do to solve for these? So this one is saying to solve for a. So that means that our goal is to get a alone. And I think a really good thing to do is if you have a literal equation and you're confused, make it into just a regular equation. So I'm going to keep a as a because I'm solving for that. But for my other unknowns, I'm going to just change those to numbers. So I'm just going to say 2a is equal to 10, and I would just try to make them easy numbers. So if I were to go ahead and solve for a, all I'd have to do here is divide by 2. And I could say a is equal to, let's just leave it as a fraction for now, as 10 over 2. Well, then I'm going to do the same thing here. When I have ax is equal to c, in order to get a by itself, I'm just going to divide both sides by x. Because remember, right here is multiplication. And what's the opposite of multiplication? Division. So these are going to cancel, and I'm going to get a is left with c divided by x. And you can actually leave it just like that. All right, let's try another one. Now this one's a little bit lengthier. It may look a little harder, but it's still the same idea. So solve for a. Again, the goal is to get a alone. Okay, and what it might look like, well, let's just put numbers in. How about 2x plus 3 is equal to 7. And what would I do? I would subtract 3 first. So I would probably subtract b first. So let's do that together. I'm going to do it simultaneously or side by side. Subtract b, subtract b. It's going to cancel here, which means it's going to cancel here. And then I'm going to have ax is equal to, now I can't combine them, so I'm just going to write it in a line. And then over here, I'd have 2x is equal to, let's just write 7 minus 3. Let's just try to keep it together. And then what would be my last step here? I would divide by 2, correct? Cancel. Well, I'm going to do the same thing here, except I'm just going to divide by x because I'm getting a by itself. These are going to cancel, and I would have a is equal to c minus b divided by x. And I actually made one little mistake here. This was supposed to say a. But again, a would be equal to 7 minus 3 divided by 2. And here, we would just say a is equal to c minus b divided by x. And I think the key thing with these is to remember if you cannot combine, write it in a line. So what I mean by that is I cannot combine C and B. So I'm going to keep it as C minus B. All right, and just a couple more ideas. This is another example. I'm going to just go through it. They want us to solve for y. So in that case, again, I want to get y alone. So I'm going to go ahead and solve this one for you. If you want to pause it, try it, and then see if you got the same answer. So I have 3x plus 4y is equal to 15. Now, the first thing I'm going to do is subtract the 3x from both sides. These are going to cancel. I'm going to be left with 4y on the left side. And I'm going to have, again, 15 minus 3x. Because I cannot combine them, I'm going to write them in a line. And then the last one would be to divide everything by 4. And I can actually write my answer just as y is equal to 15 minus 3x divided by 4. All right, so here's another one for you to try. They want you to solve for x. So we have bx minus 2 is equal to k. So my question would be, what would be the first thing that I would do here? Well, remember, I have to get rid of anything that's being added or subtracted. So I'm going to first add the 2 to both sides. And again, I'm trying to get that x by itself. So bx is equal to k plus 2. And then my last step would be to divide everything by b. So x is going to equal k plus 2. And then we're going to keep it as divided by b. Okay. Now, this just gives you some more examples. What is the value of x in the following equation? So this is a multiple choice question. So we have 2x plus 2a is equal to 6b. Now, the thing here is that if you can simplify your numbers, you want to try to. So this is an example of how we could simplify our numbers. So remember, I'm solving for x. So first I'm going to do is subtract 2a from both sides, minus 2a. These will cancel. I'm going to get 2x is equal to, now, I cannot combine these because they do not both have a's or b's. So I'm going to write them in a line, 6b minus 2a. And then my last step would be divide every term by 2. Now, here's where I actually can simplify. I can simplify, and remember, these are called our coefficients, the numbers in front of the variables. So what I'm going to go ahead and do is just divide everything here by 2. So 6b divided by 2 minus 2a divided by 2. And what I'm going to be left with is x is equal to 6 divided by 2 is 3. We still have the b, minus 2 divided by 2 is just a. So if I go back up, since this was a multiple choice question, I'd choose choice B. Whoops, would be 3b minus a. And that's what x would equal to. All right, I think we have one more example. No, we are actually done. So there was your Unit 2 review. Go ahead, rewatch any slides that you felt were important, and just be ready to take our practice test again on Monday when you get back, and I hope everyone had a great weekend. See you soon.